right? So what is an inverse function is basically, geometrically speaking, is just a reflection about the line y equals x. So inverse functions, it's just a special notation that we use for inverse functions. We use this function here, f to the power minus 1x, right? This basically represents an inverse function. It's a notation representing inverse functions. Now, what's an inverse function? Function must be one-to-one for an inverse function to exist. So for its existence, function must be one-to-one. Function must be 1-to-1. Now, what are one-to-one functions, and why does it exist? In other words, the point must be unique in order for the inverse functions to exist. So what's a one-to-one function? All functions that are increasing or decreasing are inverse functions. So basically, if you have a function of straight line, all right? Straight line function is unique. In other words, every point on the straight line is unique, right? Example, if I take any point here or any point here, any point here, these are called one-to-one function because every point is unique on the straight line. Every x value results in a different y value. So x and y is basically 1-to-1. Straight line, it can be increasing or decreasing. Exponential functions, even in exponential functions, you can look at an upward sloping exponential function or a downward sloping exponential function. Each point is unique. Every x value results in a different y value. So this is also, each x and y point is basically 1-to-1. In other words, each x value results in a different y value, okay? Let's look at functions that are not unique, right? They are basically, they are still functions, but the inverse does not exist unless you restrict the graph. So if looking at a parabola, okay, let's just take an example of a parabola, right? Now you can see on a parabola, just say if this point is x1 and this point is x2, it will result in the exact same y value. So x1 results in y1 and x2 also results in y1. So what type of function is this? This is a type of function that is many to one. There's many x values resulting in a single y value. So this is called many to one. So what are functions? Functions are always many to one and one to one. They are functions. So when will the inverse exist? The inverse will only exist if the function is one to one. Now, obviously, you also get non-functions, right? So what are functions? Functions are of the property 1-to-1. So in a 1-to-1, then the inverse will exist, right? Functions are also many to one. Many x value, the inverse, no inverse, right? There's no inverse unless the graph is restricted. Okay, so we'll come to these restrictions. So the inverse exists in only 1-to-1 functions, right? Now, let's go straight into an inverse and start solving some examples so you can understand it better. Remember, inverse function, the property is a reflection about the line y is equal to x. Forgot to tell you that. I just said so it's also a reflection about the line y equals x. That's a property reflection about the line y is equal to x. That's what an inverse function is. Now let's solve some problems. Let's see what the inverse of a linear function will be. So I have a function here. I want to see linear. If I inverse the linear function, what will I get? So how do I find an inverse of this? Very simple. You say f is the function. You rewrite this function. Y is equal to minus 2x plus 1. What are you doing now? You're trying to find the inverse. If you're trying to find the inverse, you need to reflect it above the line y equals x. This is a point xy. So now this will become yx. So you need to change, right? You need to swap the x and the y. So first step, we swap. So let's take this out. So what is the first step? The first step to find the inverse function is to swap the x and the y, always. So you get minus 2y plus 1. Now you solve for y. So you say y is equal to 2y is equal to, bring the x over, minus x plus 1. And you divide everything by 2 because you need to solve for y. So first step, you swap, right? And then solve for y. Second step, solve for y. Okay? So you say y is equal to negative half x plus a half. So that's what an inverse function. And now this is the inverse. So how would I write this inverse function? I can also write it as f inverse x is now equal to negative half x plus a half. Okay. 1 second. Now, let me do a brief sketch of this function to show you what it looks like. Minus 2x plus 1, right? I'm just going to try and sketch it on Desmo. You know how to sketch linear graphs. So I'm just going to sketch it on Desmos, right? Just want to show you what it looks like. So I have a function f of x. Let's say y equals minus 2x plus 1, right? That's what I had. I had y equals minus 2x plus 1. And the next graph, I'm just going to write down y equals, is in the form y equals minus half x minus half x minus half x plus half. Okay, so here's your inverse function here. So I'm going to explain to you graphically what that means. So the plus 1, this is your f graph, right? And this is your f inverse graph. Now, choose a point on f. If the point on f is 0 and 1, look at the point on f inverse. It is 1 and 0. Yeah, it works, right? Choose another point. Nice point to see. If the point on f is 1 and minus 1, then the point on inverse will be minus 1 and 1. Yeah, so it works. Now, what does this mean geometrically? It means that if I sketch a line y equals x, okay? So this is a line y equals x. It's not part of the graph. I'm just explaining to you geometrically what this means. And it's not an asymptote, it's just a reflection line. Now you can see each point that is reflected across the line is like equidistant. Can you see? See the point from here to there and from there to there is basically equidistant. You see, it's like reflected across. So if I fold this page in half along the yellow line, each of these points will touch, each of these points will touch this point, okay? This point will touch that point. Are we good? So it's basically symmetrical about the line y equals to x. That's what So what's an inverse of a linear function? It is linear, linear to linear, right? If you have an inverse function which is linear, you will get a linear function. Now let's move on to other types of inverse functions, okay? What happens when we have an exponential function? F of x is equal to 3 to the power x, okay? F of x is equal to 3 to the power x. So the inverse of an exponential function will end up being a log function. How? So we say f is a function y equals 3 to the power x. So f inverse is switch the x and the y, x equals 3 to the power y. Now we are solving for y, okay? So if you solve for y, you will get log x base 3. Log x base 3. You remember when I told you, you can think of it like this. 2 to the power x is equal to 7. How will I solve for x? Remember we did this brief solving for the power in what you call sequence and series, geometric sequence and series. So x is equal to log 7 base 2 to get the exact answer. So it's something like this. You're solving for y, right? So it's going to be log x base 3. The base remains the base of the log as well. Okay. So my f inverse x is now equals to log x base 3. Now let's see what this log x base 3 graph looks like, because first time you're seeing graphs of log function, which is basically an inverse of an exponential function. Now let's see what this graph looks like. So I'm going to construct a table, right? Table of values to check what this log graph looks like. So I'll take values on the exponential, right? And I'll just switch the coordinates around. So if I take values on the exponential function, x values, y values, if I take a value, remember you can take negative and positive values. If I take a value, start with positive values, start with 0. If I take 0, 3 to the power 0 is 1, okay? If I take 1, then 3 to the power 1 is 3. If I take the value 2, 3 to the power 2 is 9. What about going negatives? If I take negative 1, if I take negative 1, it's going to become 3 to the power negative 1, which is 1/3. What about taking negative 2? If I take 3 to the power negative 2, the value will become 1/9. Okay, so these are all the values on the F graph. So what are the values on the inverse function? So the values on the inverse is just switching the coordinates around, okay? So the values on the inverse is like this. This is the y value and this is the x value. So it become, this is the y value and this is the x value. So what are the coordinates? 1, 0. The coordinate is 3 and 1. These are all the coordinates of on the F inverse. What else? 9 and 2. 1/3 and negative 1. 1/9 and negative 2. See, I switched everything around. So 1, 0, 3, 1, 9 and 2, 1/3 and -1. These are all the values on the inverse function. Very important to note is that log of a negative number does not work. So we need to say log of a negative number. So x has to be greater than 0 over here. Right. So that basically becomes the domain of the function. We'll do domain and range just now after I sketch this function. All right, so let's sketch this function. So 3, 6, and 9, -3, -6, and -9. Let me see how the y values are going. Same like this, all right? 3, 6, 9, -3, right? So That's basically -3, -6, and -9, 3, 6, and 9. And you can take any other points you like, but for now, I'm just using this. Let's sketch the F graph. To sketch the F graph, 0 and 1. 0 and 1 is right here, right? Let's go a little bit lower down. 0 and 1. Then you got 1 and 3. When the value is 1, it is 3. 1 and 3 should be there. When the value is 2, it is 9. When it is 2, it is 9, right? When the value is -1, okay, wait a second. Let me change it a bit. Let me make it 1, 2, 3, right? But then again, you're going to have an issue on the other side because these are very large values. 1, 2, 3. Okay, so when the value is 0, it is 1. Okay, I'll keep 0 and 1. So when the value is 1, it is 3. When the value is 2, it is 9. When the value is -1, it is 1/3. When the value is -1, it is 1/3. Right there. When the value is -2, it is 1/9. You can see this exponential function is going very close to the x-axis, but it doesn't ever touch it. Okay. Now, looking at the next points, 0, 1, it becomes 1 and 0. Next point becomes 1 and 0. When the value is 1, it is 3. 1, 0. When the value is 3, it is 1. 3 and 1. 3 and 1. X value is 3, Y value is 1. When the value is -1, it is 1/3. Sorry, when the value again, when the value X value is 1, it is 0. 1 and 0 is on the x-axis. When the value is 3, it is 1. So 3 and 1 is here. 9 and 2. So I can't really plot that because 9 is too far away. 1/3 and -1. 1/3 and -1, I can plot that. It's right here. I can plot 1/9 and -2, which is somewhere around here. Okay. So you can see this graph is coming down. This graph is going like this. It's completely opposite, right? Shouldn't be so flat. It should be going away. Yeah. So that's good enough. So this is a graph of F and that's a graph of F inverse. Right. So these are the reflections of each other. See this point here? There was a coordinate on F, which was 0 and 1. This was on F. Another coordinate is 1 and 0 on F inverse. Now, what's important to note here is the domain and range. See the domain of F, right? And the range of F. The domain, the X values on F that I can take is all real numbers. So X is an element of real numbers. And the range of F is Y is greater than 0. You can't take equal to 0 because that's a horizontal asymptote. Then what's the domain of F inverse? And then what's the range of F inverse? So what we do is, because we're switching, so you see this part here, I will copy there. I would say that's greater than 0. And this is ER, all right? So what is greater than 0? X is greater than 0. Domain is X values. And range is Y values. You saw what I did? I switched the domain and the range around. Okay, but remember, domain is X values, range is Y values. That's what I did. See that? That part and that part. I took it from here. Right? And that part went there. Just remember domain and range. Right, now you can clearly see that the domain of the log function is X is greater than 0. That's what I mentioned here. You can see X is always positive because the log of negative number is undefined. See, try log base 3 of a negative number like -2. See what you're getting, math error. Try 0. Log of 0 is also undefined, okay? Because you substitute in an asymptote, you can't, vertical asymptote. Try -1. It doesn't work, okay? So you're getting math errors. Right, so I hope we got. Now let me just sketch it over here. 3 to the power x. So we have 3 to the power x, right? And second function we have is log. I need to look for the function with a log. Log x base 3. It's the same thing as saying log x over log 3, okay? So I'm just gonna over log 3. Yeah, so this looks a little bit more symmetrical compared to what I drew, okay? Right, so you can see this is the graph of f, right? And this is the graph of f inverse. And this is the graph of f inverse, right? So f graph was 3 to the power x, and this graph was log x base 3. All right, great. Let's move on to the next type of function. What happens if I have a log function? Then obviously the inverse of log function is an exponential. So second part, see, I have log x base 2. So let's find the inverse of this function. So you say f is a function y equals log x base 2. Remember, x, it has to be positive. That's also the domain of the log function, domain of f. That's also the domain of f is x is greater than 0. What's the f inverse? F inverse is x equals log x log y. Change the x to y, all right? So that's log y base 2. Now remember y, x is a formula, so y equals 2 remains the base as well, 2 to the power x. So log becomes exponential. So that is the f inverse x is basically equals to 2 to the power x. Right, so I'm not going to sketch it because you know how to sketch using table method. So that's the inverse function of the log function. Great. Now what happens when we have a parabola? Remember, the full parabola, this thing does not exist. Right, so for a parabola, we have parabola becomes square root. How? See, we have x is greater than or equal to 0. I'm giving you a domain of the parabola. If I tell you the domain of the parabola is x is greater than or equal to 0, you must have an idea of what we need to take. We can only take this part of the function. X greater than 0 means y is also positive, right? So this is out. That piece of the parabola is out. So there's your function, which is, this is basically 1, 2, 1, right? It's unique. So we're going to say f is a function y equals x squared. So f inverse is a function x equals y squared. Now you need to solve for y, okay? Solving for y gives us plus minus the square root of x, okay? Now if looking at the domain and the range, domain of f is x is greater than or equal to 0. The range of f is y greater than or equal to 0, right? Now, should I take the positive square root or the negative square root in this parabola? So it's nice to work out the domain and range of the f inverse. F inverse, the range, the domain and the range. Right, so the domain of f inverse will be x greater than or equal to 0, and the range of f inverse will be y greater than or equal to 0. It's basically just copying this part there, copying that part there. Right, so we know that this will be in the first quadrant, so it can't be negative. So y is positive square root of x. Okay, so that is my inverse. Now, how will I sketch the positive square root of x graph? It's going to be that graph there, right? So what we get is something like a fish. See, one is going up, one is going, it's like a fish. See, there's a tail here, there's the eyes, right? So we call it a fish. You get either you get a fish or a bird. So in this case, for parabola to square root function, for the inverse function, you either get a fish or a bird. If you sketch the whole thing, you get a fish or a bird. Now, how come the square root function looks like that? Is because I have taken some values. You need to check why this function is like this. So you need to substitute, you know, the table method, y equals x squared, choose a range of values. So I will do it here. Y equals x squared, right? And the inverse was square root of x. All right, so you can see it's only this piece of the graph. Can't take the other side, okay? Right, so you can clearly see you're getting a fish. So this is the f graph, right? And this is my inverse function. Great. Next, I still have square root. Now, what happens if I have a square root? If I have a square root function, then the inverse right, so now this is saying square root of x. I should change this domain to not less than 0. Let's make it greater than equal to 0, the domain. Well, the x can't be less than 0. X should be greater than 0. As you can see, everything under the square root must be greater than 0. So the domain of f is x is greater than equal to 0. And the range, you can clearly see there's a negative in the front. So the range of f is y is less than equal to 0 because of the negative. So f is a function y equals negative square root of x. Okay. Now, if you try to work out the domain and range here, what's f inverse? X equals negative square root of y. If I square both sides, you'll get x squared is equal to y. I'm squaring both sides because I'm solving for y, all right? So there, I have a function y equals x squared. So f inverse is basically equals to x squared, but with the restrictions. What is the restriction? What's the range of f inverse? What's the domain of f inverse? And what's the range of f inverse? The domain of f inverse is x is less than or equal to 0. The range of f inverse is y is greater than or equal to 0. So what's the restriction here for the domain? X must be less than or equal to 0. Okay. Now, in other words, it's the left side of the parabola. So let's sketch the f function first. Square root of negative x, right? This negative square root of x is this function over here going down. That's negative square root of x. And x squared, you know, is on the left side. So we chose this side. So this basically is a bird. A bird you draw like that. Okay, so that's what it looks like. It's a bird. Okay, so this is the inverse function. This is my f inverse. All right. Now you can take some points on the graph. Obviously, I expect you to know how to draw a square root function. If you don't know how to draw a square root function, we take some values. Let's take a value 0, then a y value is 0. Let's take a value 1. If I take 1, then the y value is negative 1, right? If I take 4, then the y value is negative 2. So 4 gives me negative 2. So what are the points on f? 0, 0, 1 and negative 1, 4 and negative 2. So what are the points on f inverse? 0, 0, switch these around, -1 and 1, and -2 and 4. You can clearly see that those are the points. So 0, 0 is there, -1 and 1. So if this is -1, that's 1, and that point is -4, then that point is 2. So all these points are there. So you can just use table method to sketch the square root function. Now, in general, what are the different types of square root functions? So after this, we're going to start solving problems, all right? So we know the different types of square root function. Obviously, this is, C is a sideways parabola. So this part here is a positive square root of x, and this part over here is negative square root of x. Now watch, you can also get a parabola this side. But you remember, for inverse function, you can only take a single piece to draw. So this is positive, is above the x-axis, is positive square root of negative x. Why square root of negative x? But the x value is negative, right? Because it's on the left-hand side. And this is negative square root of negative x. So these are the types of square root functions you can get. So you got 4 square root function. So you can get square root of x, y1, but x is greater than equal to 0. What's the range? That's the domain. The range is y is greater than equal to 0. Second function you can get is negative square root of x, where the domain is positive, but the range is negative. The third function is this top one here, positive square root of negative x, square root of negative x. In this case, the domain is negative. It has to be negative. Negative and negative will cancel out, and the range is positive. And the fourth one is negative square root of negative x, where the domain is negative and the range is also negative, right? So that's the fourth graph. That's y4, that's y3, y1, and y2. Okay, so these are the domain and range for each of these types of graphs. Okay, right, so now let us solve some past paper problems and see how we can solve them. Right, so this question is coming from Western Cape. Right, so let's see. We have the graph of p to the power x, which is 2 to the power x plus q. Right, so this function is 1 to 1. Passes through the points a 0, 3, and b 2 and 6. It passes through those 2 points. Calculate the value of q. How can you calculate the value of q? That's very easy. Just substitute any one of the points that lies on the p graph. So p is a function y equals 2 to the power x plus q. Wait, we don't need to find the value of q. Q is easy, just the horizontal asymptote. But how do you get the horizontal asymptote? Let's find the equation first. You have to substitute a point. So let me substitute 2 and 6, okay? So y value is 6, 2 squared plus q. 2 squared is 4, so the value of q is equal to 2. So this value is 2. Y equals 2 is the horizontal asymptote. So we got the value of q. Right. The graph P is translated 2 units down. They're asking some transformation question to obtain k of x. Determine the equation of k inverse x. So first, translate this graph 2 units down. If you translate this graph 2 units down, it was at 3, it's going to cut at 1 now. So 6.2, we got P is a function y is equal to 2 to the power x plus 2. That was a function. But now you are translating it 2 units down to k of x. So what's k of x? Y is equal to 2 to the power x, because you have to move down 2 units, right? So plus 2 minus 2. So plus 2 minus 2 cancels out, you get 2 to the power x. You need to find the inverse of this function. So k inverse is x equals 2 to the power y. So y is now equals to log x base 2. Right, so nice question. For which values of x is k inverse x less than or equal to 0? Okay. Now, it's nice to draw this graph, and try to understand what they're trying to ask us here, right? So K inverse X. So remember, this is the exponential function, which is K of X is going through 1. And then the log function is going through 1 there. So we want to know, when is K inverse X less than equal to 0? So when is K inverse X less than equal to 0? You can see this bottom piece below the X-axis. So between 0 and 1. So what's the answer for this? X is between 0 and 1. Not including 0, but we can include 1. Or you can write it like this. Okay. Next one. What is P x plus 3 times K inverse X minus 5 is greater than 0? How are we supposed to solve this problem? Something very different and unique. (6.3.2). When they say P x plus 3, it means P of x plus 3 means moved 3 to the left. The P graph is moved 3 to the left. So in other words, your function will become 2 to the power. So your function now becomes 2 to the power x plus 3 plus 2. That's what P, that's what the new function is if it's moved 3 to the left. Okay. And see what they're saying here, K inverse X minus 5. That means is moved 5 to the right. Now K inverse is basically that function there. So that's log X plus that function becomes X minus 5. So you're basically taking the product of this and saying when it is positive. So I'm going to redraw this graph because it's a very difficult question. It's level 4 type question, trying to understand this. So remember, we still have a horizontal asymptote here, right? Which is at 2. If I substitute 2 to the power 0 inside here, if I substitute 2 to the power 0, you get 3. So the x-intercept, the y-intercept now changes. That's what your function is now. 2 to the power 0, that's 3. 2 cubed is 8, 10. Okay. Your y-intercept is 10 for this point here, all right? This x minus 5 means this graph of log x was moved 5 units to the right. So it was intersecting at 1, now it's intersecting at 6, right? And obviously, if it's intersecting at 6, if that is moving, if that graph is moving, then the vertical asymptote is also moving. Remember, there's a vertical asymptote in the log graph. See this vertical asymptote, the log graph never ever touches the y-axis. So that vertical asymptote will also move. Okay, so the vertical asymptote is now at 5. So we want to know the product of these two functions is positive. So we want both the graph to be above the x-axis, okay? So let's call it f and g now. So let's call this graph f and let's call this graph g. So f times g must be above the x-axis. So when is the graph above the x-axis? When it's after 6, and this whole thing is already above the x-axis, so we can take everything here, okay? But we can't take values less than 5 because then that point will become undefined, right? So we can just say we can't take any value less than 5. So which means that you can only take x is greater than 6. So that's my answer. X is greater than x is greater than 6, product of two functions. So this will always give us positive, because if you take any value between 5 and 6, that will become negative, and this is always positive. We can forget about that. And plus, with the log function, with the restriction, you can't take less than 5. Remember, there's a restriction for log. Remember, everything over here must be, you can only take values of x which is greater than 5. Okay, that's your domain of this function here. The domain is x is greater than 5. So if I can only take answers greater than 5, it means that if I take anything greater than 5, if I take any value between 5 and 6, it's going to be negative. I don't want a negative answer. I only want positive answer. So this is my answer to this problem. So what's the answer here? X is greater than 6. A little bit difficult, all right? Challenging problem, this. If you're going to try to solve it algebraically, note, remember I said f times g, so that's 2 to the power x plus 3 plus 2, right? And g was log x minus 5 base 2 is greater than 0. See, it's difficult. What we can say is that this part is always positive, so forget about that. So now let's look for the negative part of this, right? Sorry, let's look for the positive of this. So the positive of this is, you can convert this, you can say this is 2 to the power 0 is x minus 5. I'm converting it back to exponential. So x is greater than 2 to the power 0 is 1, 1 plus 5 is 6. We got the same answer using algebra. Right, so avoid algebra, you can just use the graph. Right, very challenging question. Next one, if P is reflected about the horizontal asymptote and translated 3 units to the left to form h of x. See what this question is asking us for. Remember what the function P was? Function P was 2 to the power x. Function P is 2 to the power x plus 2. Remember the value of q was 2. So that's the function. Let me take this graph here now and do a reflection for you, because they always ask transformation type questions in inverse function, right? Let's do a reflection. If P is reflected about the horizontal asymptote, if you're going to reflect P about the horizontal asymptote, then the graph is going to end up turning like this, okay? You have to look at it in terms of the algebra. Look at the distance between these 2 points here. Look at the distance between those two. And the distance between those two must be the same, which is 0, okay? So first reflect this graph about the horizontal asymptote and translate 3 units to the left. Don't know about the translation. We'll come to that. There's 2 parts to the graph. P is reflected about the horizontal asymptote. We reflected it about the horizontal asymptote and determine the equation of h of x. If you're reflecting the graph of P of x about the horizontal asymptote, your new function is, you're reflecting it about the line y equals 2. So your new function y1 will now become negative 2 to the power x, right? The asymptote doesn't change, so the asymptote will remain fixed, okay? So it's just negative 2 to the power x plus 2. See, the asymptote can't change because you're reflecting it. It's the asymptote of both the graphs. So negative, y becomes negative, the y value becomes negative. It's like reflecting on the x-axis. See, this is the x-axis. You got a point x and y. If you're reflecting it across the x-axis, what is x-axis? X-axis is y equals 0. So it becomes x and negative y, okay? But now the asymptote will remain fixed. So negative 2 to the power x plus 2. Now, if you substitute 0 here, if I substitute, sorry, remember when we said the distance between those two, this should not be 0 here. The distance between 2 should go through 1 then. This graph here should go through 1 if you're reflecting it here. So this graph here is going through 1 and coming down, okay? This graph is coming through 1. Why we know it's going through 1? Because see the difference between 2 and 3 and the difference between 2 and 1 should give you equidistant. Right, so if I substitute 0 inside here now, you can see the y-intercept is 1. So this graph is correct. And now you're translating it 3 units to the left. So translate 3 left. If you're translating 3 to the left, you're going to add here. It can become x plus 3. So now it becomes your new function h of x. So h of x now becomes negative 3 to the power x plus 3 plus 2. And that's your final answer. Okay? Let's write it in a neater form. Yep, the plus 2 is right here on the outside. Because now you are just moving this graph 3 to the left. Okay, if you're moving this graph 3 to the left, you're just going to move closer this side, right? So plus 2. So you can see you got a plus 3 there. So the transformation can get a bit tricky, but nice question, right? Good mix of problems. And just look at more examples here. Look at this graph here. You've got log x base half. And you have log x base half, write down the equation of the asymptotes. Asymptote of f. What is the asymptote of f? There's only one asymptote, it's a vertical asymptote. The asymptote is the y-axis. Because remember, the value of x can't be negative. It can only be x is greater than 0. So what's the asymptote? Asymptote is x is equal to 0, which is the vertical line, okay? Basically, the y-axis. Determine the equation of f inverse in the form. So we have a function f, which is y is equal to log x base half. So f inverse, this is 4.2 by the way. F inverse is x equals log y base half, right? Now you solve for y. So y is equal to half to the power x. And you know half to the power x is a decreasing function, okay? Now if g of x is equal to f inverse x minus 3 minus 2, determine the x-intercept of g. See what they're saying. This function is y equals, right? This is the inverse function. So 4.3. G of x is equal to f inverse x minus 3 minus 2. What is f inverse x minus 3? This here does not mean f inverse times x minus 3. It means f inverse x minus 3 is move 3 units to the left. So you need to substitute x minus 3. Sorry, it's move 3 units to the right. So you need to substitute x minus 3 in the place of x. All right, and then minus 2. That's your g of x. What do they want? They want the x-intercept of g. To find the x-intercept, you need to make g of x equal to 0. So you got half. All right, take the 2 over. Right, that's 2 to the power 1. We can make same basis here. That's 2 to the power negative 1 into x minus 3 equals 2 to the power 1. Okay. We can cancel out the bases, distribute the negative 1 inside. So we get negative x plus 3 is equal to 1. Negative x is equal to negative 2. Therefore, x is equal to 2. So will x, substituting x is equal to 2 gives me the x-intercept. In other words, the y value is 0. Take the 2 over, there's 2 to the power 1 drop. Negative x plus 3, take the 3 over 1 minus 3 is negative 2. Drop that, x is equal to 2. Yes, you can see 2 minus 3 is negative 1. Half to the power negative 1 is 2. And 2 minus 2 is 0, so it works. So what's the x-intercept of g? X is equal to 2. Write down the equation of the asymptote of g. What is the asymptote of g? It's easy. Look at the asymptote of g. The full g function is this. So what's the asymptote? Minus 2. So y is equal to minus 2. It's an exponential function, okay? Sketch the graph of G. Clearly show all intercepts with the axis and the asymptote. We want to sketch the graph of G. Come on, that's easy, all right? Now remember, half means it's a decreasing function. We have an asymptote. We have a horizontal asymptote at y is equal to -2, okay? So this is y is equal to -2. That's the horizontal asymptote. You can take some values. Remember the x-intercept is 2. So the x-intercept is 2 is right here, right? What's the y-intercept? Y-intercept making x 0. If I make x equal to 0, if I make x equal to 0, I'm getting half to the power -3. Half to the power -3 is 2 to the power -1, 2 to the power 3, which is 8. 8 minus 2 is 6. Right? And now I can draw my exponential function like that. Right? And I can put 6 here at the y-intercept. Let's take the 6 here out. Right. So this is your exponential function. It has to be decreasing because the base is half. All right. Just to note, these are the different types of exponential function that you can get. See, I'll just use base 2. This is 2 to the power x exponential function. This is 2 to the power -x exponential function, right? It's the same thing as saying half to the power x, all right? Yeah, so these are the different types of exponential functions you can get. Now, if you reflect at the bottom, if you reflect the red graph at the bottom, you can get an exponential function looking like this, which is -2 to the power x. And if you reflect the, yeah, I'm reflecting on the x-axis. No, this one here, what did I do? This red graph is not looking good. Let's take this out. Let's try it with a little bit more curvature. -2 to the power x, and this graph here. Okay, so those are the reflections on the x-axis. So the y value becomes negative. That's 2 to the power x. Yeah, this is -2 to the power -x. Right. And you just change this to a different color. Right. Yeah, that makes sense. Yeah, so I'm basically looking at a reflection. So those are the 4 types of exponential functions you can get, right? Not accounting for the asymptotes. If you account for the asymptotes, then you'll get different types of graphs, right? That's great. Let's move on to the next part. See, next one is Northern Cape paper, right? So let's see what they're saying. We have f of x, which is 1/3 to the power x. Determine the equation of g, the reflection. Now remember, 1/3 to the power x is this graph here, decreasing exponential, all right? Determine the equation of g, the reflection of f in the, see how they ask for the reflection of f in the line y equals x. It means inverse function. They want the inverse function. So f is a function, y equals 1/3 to the power x. G is the inverse function. So x equals 1/3 to the power y. So y is equal to log x base 1/3. So that's your answer. Log x base 1/3. Sketch a graph of f and g on the same system of axes. They are sketched f, right? I'm just gonna sketch with important points. 5.2. To sketch the graph, very easy. right? So we're going to take, that's my exponential function. Let's take some points. If I take x value as 0, I get 1. If I take x value as -1, 1/3 to the power -1 is 3. That's it. I just need 2 points, all right? Next one. I'll just sketch the log graph. The log graph will look like this now. It's going to start here small and then go across. So I'm just going to switch these points around. I had 0, 1 on F. Now it become 1 and 0. I had -1 and 3 on F. So on the G graph, it will become 1 and negative. No, I had -1 and 3. It will become 3 and -1. So 3 will become -1. So that point is 3 and -1. So these are all the important points that you need to show. That's 3 and -1. This is 1 and 0. And that's it. That's it. Right. So this, you're going to say this is the F graph and that's the G graph, right? Which is the inverse function. For which values of x is g of x greater than equal to -1? Now let me show you how to answer this question. Right, so 5.3. Right, so by the way, this was 5.2. Guys, you can use table method and, sketch the functions as well. Take a set of values, 5.3. For which values of x is g of x greater than -1? When is g of x greater than -1? What does that mean? So I go to -1 on the y value, right? When is g of x greater than negative? When is the g of x values above -1? Above -1, for which x values? The x values will be between 0 and 3. So between 0 and 3. Okay. For which values of x is g of x greater than equal to -1? You draw a horizontal line at -1 and see when the values, for which values of x is the graph above -1. Right, so this is y equals -1. When is the values of on G above -1? Between 0 and 3. What are the values above -1? 0 and 3. Okay. Describe the transformation of F to form graph H, where H of X is this. So 5.4. What was the F graph? F graph was 1/3 to the power X. Be careful now. Watch. And you need to describe the transformation. What is the transformation to H, which is 27 times? What's the transformation? Or what you're gonna say is, you're gonna say the graph of H is 27 times bigger than F. Hey, that might be right, but no, we are looking for something like horizontal and vertical transformation. See, 27 you can write in same basis, okay? You can write 27 as 3 to the power 3, and this 1/3 you can write as 3 to the power -1 to the power x. If you combine everything, you're going to get 3 to the power -x plus 3. What I want to do is I'm going to write it as 3 to the power negative. Whoa. Just 1 second. Let's take it as same bases. Let's write 27 as same base, okay? That's 1/3 to the power x. And 27 is 1/3 to the power what? It can't be 1/3 to the power 3 now. It has to be 1/3 to the power -3. Now you can add those two powers. You can say 1/3 to the power x minus 3. Same basis, you can add the powers. So what's the transformation from F to H? F is translated 3 units to the right to form H of x. Yeah, that's it. So another challenging question, right? but it's a nice question. So remember, these types of questions are very short, and they will ask you transformation type question that way you can like, make you think. So this is like a little bit challenging. I wouldn't say level 4, more like level 3. Level 4 question was that other one that we did. This one over here. This is a level 4. Right, so I hope you guys are understanding everything. Are now we good? You're understanding everything?
Yes,
See,
sir.
it also builds your knowledge on functions when you solve these types of problems. Okay, let's look at this Mpumalanga paper. Whoa, see what they got done. Log x base 4 over 3. Write down the coordinates of x-intercepts of f. How are we going to find the x-intercept of f? This is the function f, right? So obviously, the inverse of this log function will be exponential. But write down the coordinates of the x-intercept of f. To find the x-intercept, you need to make y 0. So the first part, making y equal to 0. So you're going to say log x base 4 over 3. So it says 0 equals log x base 4 over 3. So you're going to say 4 over 3 to the power 0 is equal to x, correct? 4 over 3. So x is equal to 1. 4 over 3 to the power 0 is 1. So what's the x-intercept? 1. You can write it in coordinate form. It is 1 and 0. Determine the equation of the inverse. So we want to find the inverse. See what form they want it in. F inverse x form. So part 2. F is a function y equals log x base 4 over 3. F inverse is x equals log y base 4 over 3. So what's y equals to? 4 over 3 to the power x. And what's f inverse x? You need to write it in inverse form. 4 over 3 to the power x. Okay? So what's the answer? 4 over 3 to the power x. Great. Now you need to sketch both f and f inverse on its same system of axes as well as intercepts with the axis, asymptotes. Also sketch the axis of symmetry. Axis of symmetry is y equals to x, okay? So you need to show that. So they're asking for quite a lot, but it's simple, right? First, you need to understand, we need to put some important points here, and we just need 2 points, right? We don't need so many thousands of points here. I'm going to draw the axis of symmetry, which is y equals to x, okay? This is the axis of symmetry, which is y is equal to x. That's a line y equals to x. This is the axis of symmetry. So you can write axis of symmetry. Well, I got 1 mark already, right? Because I wrote down the axis of symmetry. Now the next part is to look at the graph of f, which is y equals, what is f of x? The graph of f of x is 4 over 3 to the power x. No, f of x was a log function. It was log x base 4 over 3. Now you can clearly see the inverse function 4 over 3 is bigger than 1, right? Because this is bigger than 1, you're going to have an increasing exponential. This function is increasing, not decreasing now, right? Well, we can check that up. Let's substitute x value as 0. If x value is 0, y value is 1. So 0 and 1. If I substitute x value as 1, I will get 4 over 3. If I substitute x value 1, y value, I will get 4 over 3, just above there. If I substitute x value as 2, or let's substitute x value as -1. 4 over 3 to the power -1, you can flip the fraction, it becomes 3/4, 0.75. It's a point there. All right, so I can see the graph is increasing, okay? If the value is 2, right, so you'll get a graph like that. Now, obviously, if you're getting a graph like this, then what was this point? This point was 1 and 4 over 3. Let me move this point a little bit closer to the side. Yeah, that looks more like it. Right. So the point on F inverse, remember this is the F inverse function, right? And the points on F inverse was 1 and 4 over 3. And this point was -1 and 3/4. Right. Now, go switch all the coordinates around. So 0, 1 becomes 1, 0. 3/4 and -1 becomes 1, -1 and 3/4 becomes 3/4 and -1. You get a point here, which is 3/4 and -1, right? And what about the next point? 1 and 4 over 3. 1 and 4 over 3 becomes 4 over 3 and 1. You can see it's just equidistant from that line, so put a point there. It was 4 over 3 and 1. That doesn't look like 0.75 and -1. 0.75 and -1 is somewhere around here. So mm, this point here is okay, okay. Should be a point there. 1 and 4 over 3 should be there. So directly across, that makes sense. And directly across this should be somewhere around here. Yeah. So this is your F function, and that's your F inverse. What did this say? Clearly indicate which one is F and F inverse, as well as intercept with the axis and asymptotes. We showed everything there. Also sketch the axis of symmetry of F and F inverse and write down its equation. We wrote down the equation axis of symmetry. So that's over 5 marks done.